Okay, so I just came across this fascinating development in clustering algorithms called generalized k-means. It generalizes k-means for multiple Bregman divergences.
Wait, really? Bregman divergences? That sounds complex. What does that even mean in practice?
Right, so it's like taking k-means and making it way more flexible. Instead of just using squared Euclidean distance, it can work with different divergence measures.
That's wild. So it's not limited to just one type of data anymore.
Exactly, think of it as a Swiss Army knife for clustering. It includes stuff like KL divergence and even logistic loss.
Wow, so that opens up a lot of possibilities for different kinds of data. But how does it actually implement these divergences?
Good question. It uses different strategies for different divergences when scaling, which is crucial for performance.
So it tailors itself to the data type. That sounds super efficient.
Totally, but it also has some limitations. For instance, some divergences require data to be strictly positive.
Ah, right, that could be tricky. What if the data doesn't meet those requirements?
Then it provides actionable error messages. It suggests fixes like transforming the data using log transformation.
That's actually quite user-friendly. I wonder how it handles large datasets, though.
It's tested on tens of millions of points. They even have a structured streaming version for real-time clustering.
Streaming k-means. Now that sounds like a game changer. How does that work?
It processes data in microbatches. Each batch updates the cluster centers, giving it real-time capabilities.
That's impressive. I can see how that would be useful for things like social media data or sensor data.
Exactly, but here's where it gets interesting. It can also support k-methods, which is great for outlier robustness.
K-methods. How does that differ from k-means?
Great question. K-methods uses actual data points as centers, making it less sensitive to outliers.
So it seems like it's better for certain types of datasets. What about its installation? Is that complicated?
Not at all, it's designed to integrate seamlessly with Spark, and the setup involves just a few dependencies.
That sounds straightforward. I bet a lot of data scientists would love that.
For sure, and with a Python wrapper available, it's accessible to even more users now.
Python, that makes it even more appealing. So is there a downside to using this library?
Well, the evidence seems mixed on how it performs with very high-dimensional data, especially considering memory limits.
That could be a bottleneck. I wonder how they address that.
They have some diagnostics to help tune performance and avoid out-of-memory errors. It's all about balancing the configurations.
That's smart. So it's not just set it and forget it. You have to actively manage the configurations.
Exactly, it's a bit of a dance, really. You need to keep an eye on how the system is performing.
A dance, that's a fun way to put it. So what's your take on the overall impact of this project?
I think it could really democratize clustering techniques, making them easier to use and more powerful.
That's a big deal. It could lead to some groundbreaking insights in various fields.
Right? Imagine how much richer our understanding of complex datasets could become.
It's like opening a door to a whole new level of analysis. I'm definitely intrigued.
And the best part, it's all open source, so anyone can contribute and improve it.
That's fantastic. Open source really fosters innovation. Makes me wonder what features could come next.
I know, right? There's potential for even more advanced variants in the future.
It seems like we're just scratching the surface here. What a time to be in data science.
Absolutely, and this project is a great example of how collaboration can drive progress.
I feel like I'm ready to dive into clustering now. Got any recommendations for where to start?
Definitely check out the examples provided in the documentation. They're really insightful.
On it, I can't wait to see what insights I can uncover with this.
And remember to have fun while experimenting. That's where the real discoveries happen.
Totally. Let's keep the conversation going as we both explore this further.
For sure, it's exciting to think about where this could lead us.
Absolutely. Let's reconvene once we have some findings to share.
Sounds like a plan. Until then, happy clustering.
Happy clustering. Catch you later.